Hello everyone and welcome to our channel 361 Physics, and here we are going to present our first video related with electric circuit and electric current. As this is our first video, that's why we have to do some recall work, because without knowing the basic things we could not be able to solve different MCQ. So let us begin with some recall. Okay, so I have made different topic regarding this particular chapter. That's why first topic is here electric current, and electric current is the rate of flow of charge. That's why this is amount of charge and this is time. And amount of charge in general is expressed as the Q equal to plus minus Ne. Here N is integral multiple and is the charge of an electron. Okay, and positive stand for the positive charges like proton, and negative sign stand here for uh, electron or negative charges, and its SI unit is coulomb per second, or it is also known as ampere. Electric current is a scalar quantity. Okay, so this is a scalar quantity. We have to recall this. Okay, and then after uh, we have to discuss about the uh, sign convention. In generally, the direction of flow of uh, current is taken as the direction of flow of positive charges, but in in reality positive charge do not migrate. That's why we have to take the direction of flow of uh, electrons. Okay, and that will be opposite of our conventional method. That means uh, in conventional method we suppose current flows from positive terminal of battery towards the negative terminal of battery, but in reality electron flows from uh, negative terminal towards this positive terminal. Okay, so this is all about the electric current. Now we are going to discuss about the current density. In mathematical form, current density is expressed as the ratio of current to the uh, uh, area, cross-sectional area, which is held perpendicular to the direction of flow of current. And in general, its expression is I upon a cos theta, where a cos theta is uh, a component. Okay, component of uh, area which is perpendicular to the direction of flow of uh, current. Okay, so in this figure we are uh, clear that in special case the formula is this I upon an, but in general, if the angle made by a surface with the direction or normal to the surface as theta, then its component will be a cos theta, which is perfectly perpendicular to the direction of flow of current. That's why in general form this is the expression for current density. And from the formulation, okay, we can easily write the unit. Its unit is ampere, and its unit, this is cos theta, so this is dimensionless and unitless quantity, and this is cross sectional area. That's why its unit is meter square. So uh, unit of current density is ampere per meter square. And as in definition it is mentioned that the direction uh, must be included in in case of current density. That's why the current density is vector quantity, because we have already mentioned it is related with the flow of current perpendicular to the surface. Okay, that's why uh, uh, it includes the direction. So we have to um, we have to uh, uh, write current density as a vector quantity. Okay, now we are moving towards the drift velocity, and it is the average velocity of electron when potential is applied. Okay, without application of any field or electric field, we know that electron moves in zigzag path in random direction, and its average uh, velocity is zero at that time. But if we apply certain potential or external field, then these electrons will align in a particular direction, and their average velocity is known as the drift velocity. Okay, so mathematical expression for drift velocity is current upon an EV, NEA, where N is charge concentration, E is the charge of electron, A is the cross sectional area, and I is the current flowing through the conductor. And its expression, okay, so expression for current density will be I by A, and on using this expression here, we can easily get this particular expression, which is VEN: velocity, drift velocity, electric charge, and charge concentration. Okay, so from this formula we can easily say that the value of current density increases with the increase of drift velocity and charge concentration. Okay, and one thing we must be clear, that the average velocity or drift velocity of electron is uh, order of 10 of power minus 4 meter per second. Okay, so this is uh, quite small value, but uh, it is the order of minus 4, and it uh, this represents the drift velocity. Okay, so do not be confused that electron moves with the velocity of light, and it's the velocity near about the velocity of light, and uh, the drift velocity of electron is also order of 10 of power 7 or something like that. This is just a misconcept. The value of or order of drift velocity is 10 of power minus 4 meter per second. Okay, so this is all about the drift velocity. Now we are moving towards another topic, and this is Ohm's law. So Ohm's law can be stated in different way. In first case, we have mentioned here, current is proportional with the potential difference across conductor, and there are several conditions, uh, and one is that the physical conditions like temperature and pressure and rest of the things are supposed to be constant. Okay, so in this way, we can write here K. Okay, and this is what, this is proportionality constant, and this is also known as the conductivity. Okay, sorry, not conductivity, conductance. So this is one way of expressing Ohm's law, and there is another way, and this way relate the potential with current, and says that potential depends upon the current directly. And on removing this proportionality constant, we have to insert here R, and this is what, this is electrical resistance. Okay, and from these two expression we can easily say that resistance and conductance are inversely related with each other, as the unit of resistance is ohm, so unit of conductance is per ohm, Simon, or mo. Okay, so this is all about the electric resistance. And now we are going to discuss another topic, and this is about resistivity. So resistivity and conductivity. So resistivity is, let me draw something here. Okay, so first of all we have to discuss these all. So resistance depends upon directly on length. Resistance inversely related with the area, and if we combine these all, we'll get this kind of expression. And to replace this uh, proportionality symbol, we have to insert one parameter here, and this is known as resistivity. Okay, so on rearrangement we can get this kind of expression for resistivity, and its unit is ohm meter in SI. Okay, and one thing we have to understand that resistivity is independent of several factors, and it only depends on the nature of material. Because if we are going to here write here area as 1 meter square and length as 1 meter, then resistivity will be equal to the resistance. So by definition, resistivity is equal to the resistance of a conductor having cross-sectional area 1 meter square and length 1 meter. Okay, so this is all about resistivity. Resistivity only depends upon the nature of material, and the reciprocal of resistivity is known as conductivity, and it is represented by rho, sorry, not rho, sigma, and this is the expression, and unit is per ohm per meter. Okay, now we are going to derive some relations which can be helpful to tackle some numerical MCQ. So here resistance is equal to rho L by A, as we know that, and we are going to discuss one condition when a certain mass of material is stretched to make a wire having length L. Okay, so as a wire uh, uh, is being formed from a given mass of material, that's why uh, total mass of material remains constant, and mass of material can be written as the product of cross-sectional area, length, and density. This is density. Okay, now from this expression we can easily find out the expression for area, which is equal to the ratio of mass and mass by density times length. On using this value here, okay, uh, here we'll get this kind of expression where rho is constant for a given wire, density is constant, mass is already constant. That's why we can get this kind of conclusion. That means resistance is directly proportional with L square. And for different conditions, suppose a wire is having length L1 and another wire, sorry, same wire is made or stretched to make its length as L2, then what will be the resistance in second case if some kind of question uh, is related with the resistance and length, then we can easily use this kind of expression. So R2 by R1 equal to L2 by L1 whole square. Now we are going to use the same expression, and here we are going to replace L length instead of this area. So on substitution of value of L from previous expression, from this expression, okay, we can get a kind of relation here, rho m by d, where rho is constant, m is constant, and d is also constant. So from this expression we can easily get this kind of result where uh, uh, it states that resistance is inversely proportional with the square of area, and as we know that area of cross section is directly proportional with the square of radius, that's why we can get a conclusion here: resistance is inversely proportional with the fourth power of radius of a wire. So by using this we can get this kind of expression. Okay, now the line here represent that uh, this expression relate the variation of temperature sorry, variation of resistance with temperature. Okay, so this is all about the resistance, and now we are going to discuss about some MCQ, because this single video would not be enough to discuss all uh, things related with electric circuit and electric current. So in next videos we are going to discuss different topic and solve different MCQ. I think for this particular topic we can make at least 4 to 5 videos. Okay, so let us begin with first question. The quantity of electricity analogous to temperature is resistance, potential, charge, and inductance. Okay, so the quantity which is analogous with the temperature. So as we know that high temperature and low temperature indicates in which direction heat flows. Okay, so in the same way, this is high temperature and this is low temperature. In the same way, we know that high potential, okay, high potential potential and low potential indicates, or simply potential difference indicates, that in which direction current will flow. So we can get a conclusion here. The analogous parameter which is uh, the parameter which is analogous with the temperature is potential. So बुझ्नुपर्छ है, the quantity of electricity analogous to the temperature, temperature सँग analogous भएको मतलब मिल्ने खालको क्वान्टिटी जुन इलेक्ट्रिसिटी मा युज हुन्छ त्यो भनेको के हो सोध्दैछ। हामीलाई थाहा छ टेम्परेचर डिफरेन्सले इन्डिकेट गर्छ फ्लो अफ हिट हैन। त्यसैगरी पोटेन्शियल डिफरेन्सले इन्डिकेट गर्छ फ्लो अफ करेन्ट। त्यसलाई हामीले के भन्न सक्छौं भन्दाखेरि इलेक्ट्रिसिटीसँग टेम्परेचरसँग एनालोगस हुने टर्म इलेक्ट्रिसिटीमा हुन्छ पोटेन्शियल। ओके, आई थिंक दिस इज क्लियर। नाउ वी आर हेडिङ टुवर्ड्स क्वेशन नंबर 2. The specific resistance of a wire varies with its length with its sorry the specific resistance of a wire varies with its. So specific resistance here represents the resistivity, and as we know that resistivity is independent of length, cross section area, mass, but it depends upon the material. Okay, so specific resistance भनेको resistivity हो जुन material मा मात्र dependent हुन्छ, हामीलाई थाहा छ। Now we are here in question number 3. The electric current in a liquid is due to flow of कुनै पनि लिक्विड अर इलेक्ट्रोलाइट मा हामीलाई थाहा छ पोजिटिभ आयन्स फर्मेसन हुन्छ है, अनि नेगेटिभ आयन फर्मेसन हुन्छ, नेगेटिभ आयन्स फर्मेसन हुन्छ, र यो पोजिटिभ आयन्स र नेगेटिभ आयन्स को माइग्रेसनले गर्दाखेरि के हुन्छ, करेन्ट को फ्लो हुन्छ लिक्विडमा। त्यसैले हाम्रो अप्सन सी करेक्ट अप्सन देखिन्छ। Okay, this could be last question for this particular video. The dimension of electrical conductivity is, okay, so electrical conductivity को डाइमेन्सन निकाल्नु भन्दा पहिला हामी के गरौँ भने यहाँ अलिकति म यसलाई इन्लार्ज वेमै भन्छु किनभने धेरै कुराको डिस्कसन यही आओस् भन्न खोजेको। पोटेन्शियल देखि कुरा गरौँ ल। जस्तो सबभन्दा पहिला हामीलाई थाहा छ V इक्वल टु IR, okay, and then after it can be written as R equal to V by I, र हामीलाई थाहा छ पोटेन्शियल भनेको के हो भने वर्क डन पर युनिट चार्ज। Okay, so work done per unit charge, and this is I. Once again here work done, let it be as it is. Quantity of charge is the product of I into T, and here is I, so it will be I square T. As we know that work done is the product of force and distance, that's why its dimension will be ml square t minus 2, and this is I square, that's why its dimension is a square, and this is t. So the dimension of resistance is m, okay, l square t minus 3 a minus 2. This is the dimension of resistance. Now I am going to use this dimension to find out the dimension of resistivity. Okay, so resistivity is equal to Ra upon L. So dimension of resistance is m L square t minus 3 a minus 2, and this is L square, and this is just L. So dimension of resistivity is m, and Lq t minus 3, because one L will cancel out here, and a minus 2. Okay, also we know that resistance and resistivity are resistivity and conductivity are reciprocal. So we have to make a reciprocal expression. That means m will be like m inverse, L will be L raised to the power minus 3, t minus 3 becomes plus 3, a 2. So our correct option is option B. Well, this is uh, all about question number 4. So this is our last question. Yeah, this is our last question for this particular video. In next video, we are going to discuss about different topic like Kirchhoff's law, yeah, and different electrical circuits, solving in parallel series combinations, and then uh, uh, like yes, potentiometer, and then uh, rest of the thing, Wheatstone bridge, and lots of things remains here. So please subscribe us and keep watching. Okay, stay tuned, and thank you for watching. Okay, thank you.